Okay, today we're going to talk about inverse trig functions. Okay. So first, let's talk about relationships with just inverse functions. What does it mean to be an inverse function? How do we find inverse functions? Switch x and y. So remember our notation. If we have a function, then we notate its inverse like this. We find it by switching the x and the y's, right? You switch the domain and range. Graphically, how would we find a inverse? It's a reflection about what line?
X equals Y.
Yes. Okay. So, a function that you're familiar with. What am I drawing here? Well, there's no asymptotes. It's x cubed. Y equals x cubed. Its inverse is the cube root. Right? So you see that relationship where we reflect over that line y equals x. Okay? These two functions are inverses of each other. The domain of one is the range of the other. Okay? So today we're going to talk about the inverse trig function. So we have talked about and worked with the graphs for sine, cosine, and tangent. We're not going to graph, but we're going to talk about the relationship that inverse sine, inverse cosine, and inverse tangent have. All right? So the first thing I want you to keep in mind, when we worked with our trig functions, our input was an angle and our output was a ratio, right? When we work with the inverse, we're going to put in a ratio. Our output will be the angle, okay? Since it's the inverse, our output is the angle. So when we answer inverse trig function questions, your answer will be an angle, okay, in radians. So I want to go through each trig function, and we're going to talk about what the graph looks like. You're not going to graph it, but what's important is their domain and range, because that tells us what we can plug in and what kind of values we get out of our function. Okay. So the first one is inverse sine. I do want to mention the notation. There's two different ways to notate it. Arc sine is the same thing as this little inverse sine right here. I'm going to draw our sine function on the board here. We all know what the sine function looks like, right? I'm going to draw it multiple periods here. Here's y equals the sine of x. What is the range of y equals sine of x? Our range. What's our range? -1 to 1, right? Our range stretches from -1 to 1, which means the domain of our inverse is -1 to 1. That's important. Write it down. The domain is -1 to 1. Okay. Now, if I take this graph and we reflect it about the line y equals x, what is it going to look like? It's going to look like this. It's going to be vertical, right? Is that a function?
No.
It is not. So in order for the inverse to be a function, we restrict the range so that we pass the vertical line test. Okay, so this is what the graph of the inverse sine looks like. You're not going to have to graph it. But what I want you to notice is the range. What is our range? We stretch from negative pi over 2 to pi over 2. That is important.
Is this every time?
Yes. What you need to take away from this is we can only plug in values between -1 and 1, since that's the domain. We are only going to get angles as answers between negative pi over 2 and pi over 2. And no other angles you will get as an answer. Okay. Now let's talk about unit circle values, because we will be referring to our unit circle to help us. Okay. If our answers are going to come from negative pi over 2 to pi over 2, what quadrants is that going to cover? Where is negative pi over 2? This is 0. This is negative pi over 2, right? Where's pi over 2? Up here at 90 degrees, right? So which two quadrants is this covering? 1 and 4. So your answers will only come from quadrants 1 and 4. Now, your angles in quadrant 4, since this is negative pi over 2 to pi over 2, your angles from quadrant 4 will actually be negative angles. So instead of 11 pi over 6, we would say negative pi over 6. Instead of 7 pi over 4, we'd say negative pi over 4. It makes it easier, actually, getting to describe them that way. Okay? But your answers, your outputs, your range is negative pi over 2 to pi over 2. All right. We're going to talk about each one, and then we'll do examples. Okay, so next we're going to talk about the cosine. The inverse cosine, we notate both ways here again. Arc cosine, and then the cosine with that little -1. We all know what the graph for y equals the cosine of x looks like. What is the range for the cosine? -1 to 1, which means our domain for the inverse is -1 to 1. Now, let's take this cosine graph again. When we reflect it about y equals x, same thing's going to happen, right? It's going to go vertical. So it's going to look like this. Is this a function? No, so once again we have to restrict the range so it will pass the vertical line test. So we're going to restrict our range from 0 to pi, so now we have a piece that is a function. Yes?
So the only difference between sine and cosine is holding part like 0 and 0
Mm-hmm. Yeah. Yes. Yeah, sine and cosine look the same except where they begin. They're cycles. Okay. So our inverse, okay, they both have a domain of -1 to 1, but here our range is different. Our range is 0 to pi. So when we're looking at our unit circle and we want angles between 0 and pi, that means we're looking at what? Two quadrants. 1 and 2. Last but not least, let's talk about our tangent function. Okay, So our inverse tangent function, we have our same notation, arctangent or tangent inverse. They both mean the same thing. You will see them written both ways in your homework, on your quiz, on your test. Okay. Let's talk about what the tangent graph looks like. Where are our asymptotes for y equals tangent?
1 and 1.
Negative pi over 2, pi over 2.
X is pi over 2 and x is negative pi over 2, right? And then we know our graph looks like this, okay? What is the range for the tangent? All real numbers, which means the domain for inverse tangent is all real numbers. Now, when we take this graph and we reflect it about y equals x, it's going to go from looking like this to looking like what? It's going to be going like sideways, right? Okay, so now we have horizontal asymptotes at y equals pi over 2 and y equals negative pi over 2. Okay, which means our range is between those two asymptotes. So our range is from negative pi over 2 to pi over 2. Look familiar? The only difference of the range is that we don't include the endpoints because we have those asymptotes there. So when we're looking at our unit circle, if I want values between negative pi over 2 and pi over 2, where are those coming from? What? 1 and 4, just like with inverse sine, right? Okay. So inverse sine and inverse tangent, we're pulling values from quadrant 1 and then negative into quadrant 4. And then cosine, he's kind of a loner. The inverse cosine, we're going to get outputs between 0 and pi, so quadrants 1 and 2. Okay? It is important to know the domain and range of these functions so you know what you can plug in and you know what kind of angles you're going to get out. Alright? So let's do some examples. Okay, I'm going to be Vanna White here. Okay, I'm going to go ahead and choose the first one. We're going to do this one first. The arc sine of negative 1/2. So the inverse sine of negative 1/2. This is going to be an angle. Since this is inverse sine, our angle is going to be between what? What's the range? Negative pi over 2 to pi over 2. Okay, our domain's negative 1 to 1. Does this fit our domain? Negative 1 to 1. Yes, so we can evaluate it. So now we're looking for an angle in either the first or the fourth quadrant that has a sine ratio of negative 1/2. Are we going to look in the first or the fourth? The fourth. So where in the fourth quadrant is sine 1/2?
Do you want us to do the negative thing?
We do need to do the negative thing.
Okay.
So what were you going to say?
Pi over 6.
Okay. Well, so in the first quadrant, a positive 1/2 would be pi over 6. So if we want to go to the fourth quadrant for the negative 1/2, we would say negative pi over 6. This actually makes it easier, right? Because fourth quadrant, we think 11 pi over 6, but we need our angle to be between negative pi over 2 and pi over 2. So we're going to call 11 pi over 6 negative pi over 6. Okay?
So you go backwards.
Mm-hmm. That's your answer. Yeah, just thinking backwards. Okay? But we have to think backwards very specifically.
So then, like, the only difference between, like, you giving us out like this and saying, what's the sine of negative
Well, okay, let's think back to your homework yesterday. On your homework, I was giving you problems like the sine of theta equals negative 1/2. And I said, give me an angle between 0 and 2 pi that satisfies this. And I expected you to tell me 7 pi over 6 and 11 pi over 6. So you gave me two answers all the way around the unit circle, right? Here, when we're talking about the inverse function, we're only talking about one answer because otherwise it's not a function. And we're talking about it being specifically for inverse signs between negative pi over 2 and pi over 2. Okay?
Did you know which quadrant?
For this one, because inverse sign can only come from negative pi over 2 to pi over 2. So that's either the first or the fourth.
Always fine.
Since it's negative, it has to be the fourth. Okay? All right, I'm going to be Vanna White. Which one would you like me to reveal? By a vowel? Sure. Inverse cosine of negative 1. Basically, where's the cosine negative 1? Okay. Pi, right? And is pi in the range of inverse cosine? Yes. Inverse cosine goes from 0 to pi, so that's good. Alright. Let's do another one. This one right here I'm going to call inverse cosine of negative radical 3 over 2. What were you saying? No, what did you say?
Oh, I said quadrant 2.
Okay, Dean says quadrant 2. Do we agree?
Yeah.
Okay, inverse cosine has to come, our answers will be between 0 and pi. Well, that means quadrants 1 and 2. Since this is a negative radical 3 over 2, it's probably going to be the second quadrant, right? So where in the second quadrant is cosine negative radical 3 over 2? Then our answer is 5 pi over 6. All right. Next, which one would you like? The top right. Okay, this shouldn't be bad. The arc cosine of radical 2 over 2. The arc cosine of radical 2 over 2. What is it? Pi over 4? If your ratio is positive, it's going to come from the first quadrant no matter what. If your ratio is negative, then it's going to depend on the function. Okay? Where are you never going to give me an angle?
Sure.
Quadrant 3. Okay, quadrant 3 doesn't matter right now. Right? Let's look at this one. The inverse sine of 2. The inverse sine of 2. Why?
Because it's bigger than 1.
Okay, what's our domain for inverse sine?
Negative.
Negative 1 to 1. Does 2 fall between negative 1 and 1?
No.
No, we cannot plug it into the inverse sine. So this is undefined. Okay, please be careful. Watch for that. Would you like to solve a puzzle? Inverse tangent of negative 1. Which quadrant are we going to go to?
4.
Fourth quadrant, right? Between negative pi over 2 and pi over 2, so we're going to go to the fourth quadrant. And where is the tangent ratio negative 1? Good, negative pi over 4. Okay, we like to think of that as 7 pi over 4, but since our range is negative pi over 2 to pi over 2, we're going to write it as negative pi over 4, which is actually easier, right? Okay. Wonderful. Okay, feel okay there? Get out your calculator. Make sure you are in radian mode. Okay, you are in radian mode. I ask you for the arc tangent of negative 8.45. Where's that button? Well, you're not going to see arc tan. You're going to see the tan with the -1. Those are just the second of your sine, cosine, and tangent. These are the buttons you've been waiting to use, right? So you're going to say second tangent of negative 8.45. To get negative 1.453.
I was gonna want to say something.
Not yet. Inverse sine of 0.2447. All we have to do is second sine of 0.2447. Okay. And these are giving us radian measures that fall in our range.
Wait, but.
Wait, what?
Never mind.
Okay. How about the arc cosine of 2? You can't. Let's just see what happens if we try to put it in our calculator. Error. Domain. Because 2 is not in the domain. So if you kind of mindlessly try to put that in your calculator will tell you, you were supposed to do that. Okay? So just so you know what happens if you try it, it's not going to work. Alright? Okay. Okay. We're going to talk about some properties with our inverse relationships. Okay. Earlier we talked about the x cubed and the cubed root of x being inverse functions of each other. Correct? What happens when you take the cubed root of x and you cube it? Cancels out and you're left with x, right? Okay, so we have that relationship with our inverse trig functions, but it's very, very picky because our domain and range is very, very specific for our inverse trig functions. Okay, so we're going to go through these one by one. First of all, I want you to look at this right here. Sine of inverse sine of x. Is x only when, okay, these can only cancel out when x is between -1 and 1 because that is the domain of the inverse function. Okay? We can only cancel those out if x is between -1 and 1. If it's not, then we have to evaluate the arc sine of x and then plug that into the sine. Okay? But really it's going to be because I have to be able to plug it in. Secondly, if we have the arc sine of the sine of y, those will cancel, but only if y is in the range, -pi/2 to pi/2. Okay, so those will cancel only if y falls in that range. If not, then we have to evaluate the sine of y and plug that into the inverse sine. Okay, and we'll see an example of that so you know what I'm talking about here. Okay, basically what you need to realize is that they're not always going to cancel because the inverse has such a specific domain and range. We can't just automatically cancel them out. Okay, we have to think a little bit. Okay, so we're going to talk about these properties with the inverse cosine. What do you think is going to be different about our rules? 0 to pi is going to be what y needs to be between. Very good. Okay, So the cosine of the inverse cosine will cancel only if x is between -1 and 1. All right. And then the inverse cosine of the cosine will cancel only if y is in that range. Okay. If I'm evaluating an arc cosine, my output has to be between 0 and pi. So our answer has to reflect that. Juniors, when are your registration sheets due?
It's next Wednesday.
Wednesday?
Is it odds on Tuesday?
Those blocks. It says it on there.
Tuesday, Wednesday.
It's
Odds.
Tuesday's odds.
So Tuesday and Wednesday is when they're due?
Yes.
Okay, thank you. All right, and then tangent. What's the domain of the inverse tangent? Nope. All real numbers. So the tangent of arctangent will always cancel to just x. But we're going to be picky with the range. The arctangent of the tangent will only cancel if our angle is between -pi/2 to pi/2. If not, then we have to work with a composite function inside to out. Okay. Now I would say, as long as you know the domain and ranges for your 3 inverse trig functions, these won't necessarily be a big deal because you will know what kind of answers you can have. You will know what kind of inputs you can have. Okay. And we'll go through these examples and we'll see when they cancel, when they don't.
Why
Okay.
is some of them like equal to and some not? Like why is it tangent equal to?
Okay. Tangent does not include pi/2 and -pi/2 because that's where we have asymptotes.
Okay.
All right. If we come back to this graph, that's where it has asymptote, so our range is only in between. All right. So I'm going to be Vanna White again here, but I'm going to go in order. Okay. I wish it was a new car. Instead, we have a math problem. The tangent of the arctangent of -5. And why is that?
Because it's always.
Okay. The tangent of the arctangent will always cancel out. Okay. Now, what if you were kind of panicking and you weren't quite sure if they could cancel or not? What could we do? We could draw a picture. Okay, we love drawing pictures, right? The arctangent of -5. Our output is an angle. Well, since it's the arctangent of -5, where is the angle? This. Right, it's either first or fourth for arctangent, correct? Since it's the -5, it has to be in the fourth quadrant. Okay, and our tangent ratio is 5/1. Okay, so this is describing an angle, and we want the tangent at that angle. Well, here's our angle. Our tangent is 5/1, and it's in the fourth quadrant, so it's a -5/1. All right, let's think a little bit. Scary, I know. We have the inverse sine of the sine of 5π/3. So my first question is this 5π/3?
No.
It is not. Our big function here, our outside function is arc sine. So my answer better be between -π/2 to pi/2. Okay, 5π/3 does not fit that. So we need to work with our inside function and then go out. So what we're going to do, what is the sine of 5π/3? Okay, so I'm going to rewrite this as the arc sine of negative radical 3 over 2. I evaluated my inside. Okay. Now we can work with the inverse sine of negative radical 3 over 2. What angle is that? Which quadrant? Okay, I want to evaluate the inverse sine of negative radical 3 over 2.
So it's in 4.
We're going to be in the fourth quadrant.
And it's going to be 5. Negative 5 over
Negative pi over 3. Remember when for inverse sine and inverse tangent we have to rotate negatively to the fourth quadrant so we can be between negative pi over 2 and pi over 2. Okay. Notice how this angle is similar to this angle. We have the same denominator. That should happen, right? Because we have the same function. Okay. Do I need any further explanation with this problem?
No.
Okay. Now, what if I said the arc sine of the sine of pi over 3? Then this can be pi over 3. Those can cancel to pi over 3. What, Ashley?
Aaron said it wouldn't work.
Yeah, this isn't pi divided to like 1
No, that's 1 by it.
The output of arc sine should be an angle.
Yeah, I know, but I'm saying like,
Are you talking about this input right here?
yeah,
But we're inputting pi over 3 into sine.
which
The sine of pi over 3 is radical 3 over 2.
alright,
And then that input is okay for arc sine.
alright.
And make you think a little bit again. Okay. How do we do this? Or what is it? Is it pi? Let's look at our inside function. The inverse cosine of pi.
Oh, no,
What?
no, it's not. It's not pi. It's not pi.
Is this okay? Okay. The input for inverse cosine, what should our inputs be? Negative 1 to 1, right? Is pi in the domain of inverse cosine?
That's the range. I'm thinking range.
No.
Cool.
Okay? We cannot evaluate this because pi is not in this domain. Now, what many of you are trying to do was this. Is this okay?
Yes, because that's the range of it.
Yeah, this is okay. Yes.
How do you know if it's the domain or range?
Well, you always need to make sure that you can plug this in wherever. So, like, is pi over 3 okay to plug into sine? Yeah, so we're okay there. Is pi okay to plug into inverse cosine? No, that's not okay.
How do you know which like limits to use? Like if it's the like -1 to 1 or whatever, so you have
Okay. Your inputs, so what you put into the function, need to be negative 1 to 1.
Okay.
What you get out need to be between.
Okay.
Okay. Good. So this one right here, could we answer this? And what would it be? All right, let's steer away from our unit circle values. It's okay.
Whoa.
If it's not a unit circle value, then we get to draw a picture. It's actually easier, okay? So first of all, inverse cosine of 2/3. That is describing an angle. Where is this angle? It's gonna be in quadrant 1, right? Our ratio is positive, so we better be in quadrant 1. Inverse cosine describes angles from quadrants 1 or 2. We're going to place it in quadrant 1 since we have a positive 2/3. So our inverse cosine of 2/3, that means cosine is 2/3, right? What's the third side of our triangle?
So radical 5.
Radical 5. So what is the tangent of this angle? What's the tangent of this angle? Radical 5 over 2. I don't know why you're packing up. I have not dismissed you yet.
Can you do that like that? Where it's arc, cosine, and then tangent at
Well, yeah, we can mix these together. There's not going to be any canceling. We're just going to draw pictures. Okay. Now I just want to talk through this one. If I have the cosine of the arc sine of -3/5, where would we draw our triangle? We'd have to draw it in the 4th quadrant, wouldn't we? Because we have a negative with our inverse sine. So we have to draw a triangle in the 4th quadrant. And then we could get our third side and evaluate the cosine ratio.
Wait, even though,
I get it.
never mind.
So it's 4.
No, I got it.
So it being 4 would be 4/5.
And it'd be positive since it's in the 4th quadrant and it's cosine. Okay, so this is your homework. Please make sure that you do it. Check your answers. Only use your calculator for the calculator ones. Everything else should be unicircular pictures. Okay? Enjoy your lunch. We'll see you tomorrow with all of your homework ready for me to check. I will also start talking to you tomorrow about classes.
Can I just talk to you now really quickly? Because I might not be here tomorrow.
And why won't you be here tomorrow? What?